this is the full stack development demonstration for Group 7. Our project name is Sky Analytics. So I am the first presenter. My name is Kaylin. I'll be presenting the not so important parts, the aesthetic parts of our website. So I'll be explaining about the navigation structure, the home section, and the about us section. So our navigation structure does hover and highlight like this. The same with these buttons here, but I'll get to that later. So the buttons stay highlighted on the page that you're currently at. So if you see the header JS, so this use location hook helps with that. It stays highlighted. In our header CS, we have these media queries for responsive design for different devices. I will demonstrate that before I end. Going back to the home page, so this is actually 2 columns. We did maintain a 2-column design here, and same with the about us section, so that when you switch to a mobile, the columns stack on top of each other and it's easier that way. So these do pop up, and this one takes you to the predict page. This one takes you to the classification page, and yeah, so that's the home page. We use navigate hook here for routing and other features here for aesthetic purposes. So the same with the about us. This is also 2-column layout, so when you switch to mobile, it stacks above each other. This is just to display the information about our team and our project. So these are just features. These hover, and we also added a little thing here. So if I click this logo and the name here, it takes us back to the home page. So now I'm gonna go into developer tools. Yeah, so on an iPhone SE, this is the layout. For visualization, it would be better to turn it this way because the graphs do look compressed, and it would be hard to see each individual plot on the graph. So yeah, this is how it would look. On a bigger mobile like this, it's the same, just about the same. On a tablet, we go back to the 2-column layout. And that's it from me. The next portion of the demonstration is the predict section of the website, and that will be done by Jamin.
Hi, I'm Jamin, and I will be demonstrating the predict page, the heart of our Sky Analytic application. Let me show you how we predict flight delays using 3 different machine learning. This is our predict page where users can analyze flight delays. We have a clean interface with drop-downs for different filtering options. Notice the semi-transparent overlay that makes the form readable while showing the airplane background. As you can see, our main predict page component, we use React hooks for state management, form data for user inputs, char data for results, and loading states for UX feedback. We have built-in validation to ensure users selected required fields. The delay cost is mandatory because it determines which data we analyze. Optional fields like year, month, and carrier help refine the analysis. Let's go back to the browser and we choose carrier delay, and we click linear regression. As the model processes, let me show you what's happening behind the scenes. Here's our linear regression implementation. We use all other delay type as features to predict the target delay. This creates a multivariate regression model. And this fast API endpoint receives the request, maps the user-friendly delay names to our database columns, and routes to the appropriate machine learning model. Let's go back to the browser and our linear regression results are in. We show two visualization, which is a line chart comparing actual versus predict delays over time, and a bar chart for direct comparison. The blue line represents actual historical data, while the red dashed line shows our model's predictions. Let's choose the k-means clustering. For it process, let me show you the API communication layer. This is how our front end communicates with the back end. We use Axios to send post requests to our fast API endpoints. The requests include the model type and selected delay cost. For k-means, we cluster based on patterns with a single delay type. We use two clusters for faster processing and standard scaler for normalize the data. Let's go back to the browser. K-means has grouped similar weather delay patterns into clusters. The color points show how different clusters and the histogram shows the distribution of delay times. This helps identify common patterns in weather-related delays. Let me quickly show you how the third model, which is dbScan. Okay, this is the dbScan results. In summary, our predict page demonstrates three different machine learning approaches to flight delay analysis, back-end communication using fast API, beautiful and interactive visualization with Poly. The system successfully processes user inputs, run machine learning models, and presents actionable insights through intuitive visualizations. Now we will move to the visualize page.
Hi, I'm Wicket. Let me to continue demonstrate Sky Analytics advanced visualization capabilities and the responsive design that makes our platform accessible across all devices. Our visualize page immediately established an aviation theme with this beautiful sky background. The interface is designed to be both visually appealing and highly functional. Here you can see our dual filter system. User must select both a cost of delay and an AM model to proceed. The red asterisk indicate required field, and the search button remains disabled until both selections are made. This prevents unnecessary API calls and guides user towards successful interaction. Now, let me demonstrate with a linear regression analysis for arrival delay. When we click the search button, you will see how seamlessly the system processes the requests and generate the interactive visualization. This one is the result for linear regression with the arrival delay. Now let me explore k-means clustering. This algorithm similar delay pattern. This algorithm groups similar delay patterns into clusters, helping identify common characteristics in flight delay. One of the most powerful aspects of our implementation is the interactive nature of this visualization. User can zoom the specific time period for detailed analysis, pan across the timeline to explore different patterns, hover over data to see exact values and timestamps. This level of interactivity transforms the static data into an exploratory experience. Now, let me showcase our comprehensive responsive design system. We have used Sky Analytics to provide an optimal experience across all devices size. Notice how every component adapts gracefully. The navigation header transforms from horizontal to vertical layout, from elements stacked in a single column, and all interactive elements remain fully functional. On tablet device, we maintain a hybrid approach. Some multi-column layout remain while others adapt to the medium screen size. This ensures user gets the best possible experience regardless of their device. Now, let me demonstrate a complete workflow on mobile device. Okay, I will select the NAS delay, which stands for National Airspace System Delays, and analyze it using DB-scan clustering to identify outlier and dense pattern. Even on mobile device, our loading state will provide a clear feedback. The system is processing complex machine learning algorithm, and we keep user informed throughout. Here you can see the complete result on a mobile screen. The chart remains fully interactive. Users still can zoom, pan, and hover. The information section adapts to the smaller screen while maintaining readability and functionality. To wrap up our demonstration, let me show you the DB-scan implementation that power this analysis. DB-scan density-based spatial clustering of application with noise is particularly valuable for the flight delay analysis because it naturally identifies outlier without requiring pre-specified cluster count. Our implementation uses standard scale for data normalization to ensure fair distance calculation. Optimize parameter with EPS equal to 0.3 and mean samples with 2 to balance for accuracy and performance. An automatic outlier detection where noise points are labeled as -1. This allows us to identify unusual delay patterns that might indicate operational issue or extraordinary circumstance. In conclusion, our visualize page combines complex machine learning analytics with an intuitive, responsive interface that works seamlessly across all devices. We have created a platform where complex data analysis become accessible and engaging for user everywhere, whether they are on desktop, tablet, or mobile. As you have seen, Sky Analytics provide a comprehensive platform for flight delay analysis with a focus on user experience. Our integration of multiple machine learning models with a responsive React front-end and fast API backends create a powerful analytic tool. The responsive design ensures accessibility across all devices, while visualization capabilities make complex data understandable. That's all in our demonstration. Thank you for watching our Sky Analytic demonstration. Thank you.